Hello everyone, it's Linux Robot Geek again, and we will be returning to the LED Flask application that we did a while back. In part 2, we learned how to use Flask and GPIO 0 to control an LED. In this video, we're going to package the application with Docker. In this video, we will learn about what Docker is, how it works, we'll learn about the commands, and we'll learn about the various files we will need to get this running. So let's get started. Welcome back. So, in order to package our application with Docker, first let's talk about what Docker is. According to the website here, the main Docker website, the article says, a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. Basically, what we're dealing with here, a container is essentially code that is packaged. So for example, if you wanted to package a web server or a database client, you would use Docker for that. So in this picture here, you'll see an example of that. Here we have the infrastructure layer, which would be our PC. And then we have our host operating system, which is Linux in this case, but it could also be Windows or Mac. And then you have Docker running, and then you have 6 example applications. This means that you can run 6 applications in one PC without wasting resources or having to buy extra infrastructure. This is a better solution than having to use virtual machines, which require different operating systems running on one server, for example, and that costs a lot of money and maintenance. So using Docker is a better solution if you want to run multiple applications on one PC, for example, or if you're running it on a server. So this pretty much tells you Docker, and of course here is the image comparing the containerized applications with the virtual machines. And as you can see, containerized applications have actually improved over virtual machines and are the preferable methods to run our applications. Now, let's talk about what we will need to containerize our application. First, let's talk about our main app files. So here we import our libraries. So we import Flask, render template, and request from Flask. We import LED. Then we import the PyGPIO factory. Then we define our factory with the IP address of the host. Change this if you're using a different IP address. Then we define our LED with our pin number and the factory. We define the name of the app. Then we define our routes. So we have our main route, which is our template. Then we have our on and off routes, which turn on or off the LED. Then we will run our host at 0.0.0, and this is necessary for Docker. Then we have our Docker file here. So we have from Python 3.8 Slim. This simply means that we will build our image using Python 3.8 Slim. Here we copy all the files from the current directory, which is shown in a dot, to app. Then we will make app our work directory. Then we will install the requirements using this command. And then cmd simply means it will run the command python app.py or whatever command that is used in this section. Speaking of requirements, this requirements file shows what is necessary. So in this case, we have Flask, GPIO, and GPIO 0. You need to put a double equal sign on all the packages and also the versions you will be using. So with that in mind, let's actually run the application. So I already have the Pi running. As you can see, I have sudo pi gpiod running, so pi gpio is now running on the Pi. Now, in order to build our image, first we'll have to do docker build t. We'll call it Python LED. We need the dot because the Docker file is in our current directory. So we'll press enter, and it's going through each step. Now, I did run this last time and I messed up. And as you can see, it is working now since we now have everything working. Ignore this warning because it simply says don't run it as a root user at all. But just ignore that warning. Now, in order to make sure it built, we can do docker images. And as you can see, Python LED built 13 seconds ago. Now, in order to run our application, we'll have to use docker run, and then D for detached, P for port, and then 5000, and then Python LED. Give it some time, and it creates a hex number. Then we do docker PS, and it's running on port 5000. So we'll go here, we'll exit out of that, we'll go to 0.0.0.0 5000, and of course it should be running now. So the LED is blinking. So in our demo you will see the LED blink live, so stay tuned for that. Quick video update, I forgot to add this. So I did not mention how to install Docker, so I'll do it here in this segment. Now, this is used to install Docker Engine on Ubuntu. So these instructions are for Ubuntu, but I will provide the link below so you can install Docker on your own distro, or if you're using Windows or Mac. So the easiest way of installing it is using a convenience script, which is located here. So in this case, you would curl it, then you would run the sh command under sudo, and it should run. So in my case, I have the script already here, and I installed it using that option. Then after that, you want to make sure to add the Docker group, or essentially create it. Then you need to add your user to the Docker group. So it would be sudo usermod ag docker and then user. So make sure to do that before you run Docker. Then you log out and then log back in. And then to make sure the changes work, run docker run hello world. And if it does, then you did it properly. So that's just a quick update on that. I will provide a link so you can install Docker on your own. So let's get started. Alright guys, here is the demo, and as you can see, when I press the button, the LED blinks. The blue LED wouldn't work, so I'm using the yellow LED instead. And as you can see, the application's running on the screen. So when I press it, it should work. Now you can also follow what's going on with Docker logs, and then we will copy the container ID, and then see, it tells us that we are turning on and off the LED. So as you can see, we finally got it to work now, and the LED is turning on and off. So if I hold the mouse, it's on, and if I release it, it's off. So that's it for this demo. Thanks for watching this demo. So that ends another successful demo. Now, before I end this video, I want to mention that you can stop the application with docker stop and then the ID of the container, and that should stop your application. So while we have successfully deployed this application, now we want to use Docker Hub to push this to our repository. So in next video, we will be doing that. But we will also be adding monitoring to our Flask application. So in the next video, we will be adding Prometheus to our application, and we will be pushing our Docker image to Docker Hub. So that's it for this video, and see you guys next time.